All right, guys. So we just got done talking about logarithms and just how to convert exponential, well, why logarithms are here, how to convert them from exponential into log and log back into exponential forms, okay? And that's actually what all we need to know. So just as a quick reminder, actually better yet, let's recall the notes from last time. That's what we really need. So if we ever want to convert from log to exponent, right, we have a base, exponent, and the answer. The base is written as a subscript. The answer is written on the same level as the log, and then the exponent is now, the exponent is now the answer. Okay, so if you looked at it when we converted it before, it was 2 to the x equals 7, right? Well, if we had to convert it into log form, log would be the operation, 2 would be used as a subscript. The answer was 7, we knew that, and of course we're solving for the exponent. And now, if you notice, it was the only thing that grabbed the x from out the sky of the exponent and put it down on the same level. That's what we need when we're solving for x, okay? So this is the problem I left you with, so let's do the same thing here. Log, what was the base that we used? 6. What was the answer? 3. And what would be equal to? X, okay? And yes, log base 6 of 3 is a number. The question is whether or not it's a number that we know, okay? So sometimes logs evaluate nicely, and we're going to talk about it. That's the whole focus of today's lesson, is evaluating logs, okay? But some of them evaluate nicely. Like this guy evaluates nicely. And if you guys, I'm going to show you how to do these guys. This guy ends up being the number 2. Well, this guy does not end up being a number 2. Why? Because he's irrational. Okay, so there are some logs that are irrational and then some logs that are rational. It's kind of like how there are some roots that were good and some roots that just didn't simplify. Okay, this is 2. That was square root of 3. So the same way roots, which was the other exponential, like inverse guy, right? Well, he has some guys that were beautiful and some guys that did not completely work out perfectly. We also are going to have logs that are kind of the same way, all right? So we're going to need to know how to think about them to determine whether or not they're going to work out or whether or not they're not going to work out, okay? But we're still going to know how to evaluate them even if we're going to approximate them. So that's how we're going to have to approach this issue. Okay, so here we go. Let's talk about it before we get started. So all we got to do, and this is the idea, we're more comfortable thinking in exponential form. Okay, so what I want to do is I want to show you how to evaluate logs, but I want you to take you back to your comfort zone, okay? So let's say we had to do this. I said, right, evaluate. So again, let's say I had evaluate these logs. Evaluate the following, okay? Well, let's say it's log base 5 of 25, okay? And remember, keep in mind the position of things, okay? So I'm going to write down the same thing we had on the other page right here, but just so we can reference it, okay? Log, the base of, I don't know, this is a base. The answer is here, and it's equal to the exponent. Well, that's the same thing if we were to convert it. Take that base, it's raised to the exponent, and then it gives you an answer, okay? So what I'm going to tell you is if you don't know what this is, convert it. It makes it easier to think about. So check this out, okay? So here we go. Let's say I said do this problem. Well, let's say I don't know what it is. Well, what would be my justification? What's my justification? Well, my justification would be this. Would be the base is 5. I have to raise it to the box exponent, whatever that's in that box, and maybe I know what it is, maybe I don't know what it is, and I can approximate it, one of the two, okay? But all of this work is going down in my head, and it should be equal to 25. All right, so now use your guys' magical brains and start playing the game. Well, what's going to get me to 25? Well, 1 is just 5. If I put 1 in that box, well, 5 to the first power is just 1, so that's no good. But 5 to the second power, that's it, okay? So the answer is 2. So note, in order to find the answer, we have to convert back to think about it, okay? And you'll get to a point where you're really, really good at stuff, and then you won't have to convert it as much on paper. You'll be able to do it in your head, because ideally, we shouldn't have to do any of this work, and all we should have to do is just say that the answer is 2, okay? So let's try to do a couple more of these, all right? But it all comes down to converting it, okay? So we're going to try to do it in our heads, and I'll give you a second, and then we'll work through it. How about this one? Log. So this is the second one. We're going to try to evaluate this. Okay. Log base 10 of 100. Okay. So here we go. The base is 10. I'm going to talk it out this time before I write it out. The base is 10. We're looking for the answer. The answer is the exponent. And it's equal to 100. What does it have to be? So y. Well, what's the logic? Box. Well, that means 10 to the box has to give us 100. What does the answer have to be? Okay. So if you need to, just keep writing out. Eventually, the logic will be just burned on your brain. Okay, so converting it will make you guys really, really good. How about this one? Log, this one's a little tougher, of 1 over 10. Yeah, what's that one? All right, so sometimes converting it is necessary. That's why I always say it's not unnecessary to know how to do this, because some of them will get very, very hard, and converting it will make things really, really easy. So why? So you'll notice everything we'll do, we'll convert it back to think about it. The base is 10, right? The exponent we're looking for, the answer is 1 over 10. All right, so now you guys know your laws of exponents. 10 to what power is 1 over 10? And because you guys are pros at the laws of exponents from chapter 1.6, I know you guys know that this is going to be -1. So the answer is -1. So ultimately, logarithms are not hard. It's just, do you know your exponents yet again? So, because remember, they all pivot on exponents in a bigger kind of way. All right, so here's a few more. I want you to pause the video, all right? I'm not going to put the Y down. Pause the video, try to get the answers out. I'm going to write all 3 of them down and let you guys do all 3 of them, and then we'll look at them, okay? So here's one. Log base 25 of 5. Log base 5 of 1. Log base pi of 1. Yeah, I know pi. It's really freaky. All right, pause the video and see what answers you get, and then I'll see you back in a second. All right, so I'm assuming you guys paused the video, and if you didn't, then oh well. Then here we are. So what's the answer that you guys got? So let's see here. All right, so each one of these, I'm just going to start with the first one. Okay. The first one, this is going to be equal to box. So here we go. Well, why? What's the answer? What's the justification? That the base being 25 raised to that same box has to give me 5. All right, so now you got to think about all of your laws of exponents. Which ones do you know? Well, I'm trying to shrink 25 down to 5. What do you think you probably need to do? Maybe take a root of some sort, right? So I'm thinking fractions. Fractions are important. Fractional exponents, right? So this guy is to the 1/2 power. If you remember, we'll be taking a straight up square root of this guy. So that's to the 1/2 power. Pretty simple, right? But you have to think about it backwards, and that's what makes it hard. Okay, so now we're not just evaluating exponents like we have been doing in the past. You're thinking about it reversely. Okay, so you got to convert it. Always convert it, and then play around with the numbers. And as you play with them, promise you, it will get better. All right, here we go. So let's see if we could do this one. Okay, so what's this saying? Well, let's convert it. This is saying, well, the base is 5. All right, the answer, the exponent is going to be the box. We don't know what the box is. And what should it be equal to? 1. All right, so what did you just figure out here? That's right. So this is actually 0, isn't it? Isn't that cute? All right, what'd you guys get for this one? All right, let's see. Well, again, I'll put a box here. Why? Well, let's see here. Because pi was the base, the box is the exponent, and that has to be equal to 1. All right, so now something else has just happened. So after you do that, what does that exponent have to be? Even though I don't really know how to do pi to any exponent, because pi is irrational, exponent has to be 0, because anything to the 0 power is 1. Okay, so very, 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 very easy, but at the same time, it can be extremely, extremely, extremely difficult if you're not careful. And here's a hint. This is actually a very, very special property. Okay, but I'll delve into that when we start talking about the laws of logarithms as we step into the next part of 9.3. All right, guys. So this is basically it. If you need to evaluate, convert it back into exponential form, and then think about your laws of exponents backwards. You might need to do a root in there, right? Which means a fractional exponent. If you need to make it a fraction, you might need to make it negative, right? You might just have to think about it in a different kind of way. Okay. Now, before I let you guys go, I think it's important to look at a few more of these in a much more critical way, I think. No, I think this is good for a basic stop. We'll stop here. All right, guys. See you on the next video.